In this video, we will start with the basics of friction. What exactly is friction? First of all, friction is a force. It's a force that opposes motion between two surfaces that are in contact with one another. Secondly, friction always acts parallel to the surface, which means that if the surface is horizontal, friction will act horizontally. If the surface is an inclined plane, friction will act along the inclined plane. Now let's talk about the idea of smooth versus a rough surface. A smooth surface offers no resistance, or practically the resistance is negligible. So we don't even consider it. On the other hand, what is a rough surface? A surface which gives rise to resistance, which gives rise to friction. Such a surface is known as a rough surface. Now let's consider three different scenarios. We have a surface that is made of glass. We have another surface that is made of wood. And then we have a third surface that is made up of sandpaper. Which surface out of these three will give the least resistance? That would be glass. And which will give us the maximum resistance? That surface will be made of sandpaper. Wood would lie somewhere in between. At this point, we can introduce the coefficient of friction, which is denoted by the symbol mu. So it's pronounced as mu. This is the symbol that we use. This gives us a measure of the roughness of the surface. How much resistance does it offer? In a smooth surface, the value of mu is 0. That means there is no friction. For rough surface, the value of mu increases from 0 upwards. Now let's take the example of a book lying on a surface. So there is a book and there is a rough surface. Now, in the first case, there is no applied force on the book. If there is no applied force, there is simply no friction. Now let's look at the second scenario. There is this force over here, which is P. P is an applied force. It could be a push or a pull. When I'm applying this force, the particle is not moving. First of all, in which direction is the frictional force acting? It's acting in the opposite direction because friction opposes motion. And friction always acts parallel. This is the symbol I'm using for parallel to the surface. Now, since the particle is not moving, the book is not moving along the rough surface. In other words, the applied force is not big enough to make the particle move. Now, in the third case, again, I'm using the same symbol for the applied force. And this is the frictional force. If I keep on increasing the applied force, the value of F, the frictional force, keeps on increasing till it reaches a maximum value, a limiting value. This value is known as Fmax, the maximum value of friction. Only if the applied force is greater than Fmax, the particle will move, the particle will accelerate. Now the question is, how do we evaluate the maximum value of the frictional force? Fmax is given by the formula that is a product of mu multiplied with r. R is the normal reaction force and mu is the coefficient of friction, and Fmax is the maximum value, the limiting value of the frictional force. Now let's do a simple example related to this concept. Now over here, I have drawn a figure and I have taken the mass of this particle to be 2 kg. Acceleration due to gravity is 10 meter per second square. The coefficient of friction of this particular surface is 0.4. First of all, let me evaluate the weight of the particle, which is m multiplying with g, which is 2 multiplying with 10, which comes out to be 20 Newton. Since the weight is acting vertically down and normal reaction force is acting vertically up, and there is no other force acting in the up or the downward direction, therefore the value of R is W. The value of R is 20 newtons. Now let's evaluate the maximum value of the frictional force, which is mu multiplying with R, which is 0.4 multiplying with 20, which gives us a value of 8 Newton. So now this is the applied force P and the frictional force is acting in this direction. Now I have not yet labeled the frictional force to be Fmax. I have only evaluated it, and the frictional force opposes motion. The frictional force acts to the left. Now let's say the value of P is 1 Newton. This 1 Newton is lesser than 8 Newton, so therefore the particle won't move. Let's increase the value of P to 7 Newton. Again, it is lesser than 8 Newton. The particle still won't move. Let's increase the value of the applied force to 8 Newton. Now it's equaling to this particular value of Fmax. Still the particle won't move. But what is the value of friction in all the three cases? According to Newton's third law, action and reaction forces are equal but in opposite direction. In the first case, the value of F is also 1 Newton. In the second case, the value of F is 7 Newton. In the third case, the value of F is 8 Newton. But now the friction won't be exceeding this particular value. What if the value of P is 8.1 Newton? Now the frictional force will have reached its limiting value, its maximum value, that is 8 Newton. It cannot increase any further. Since 8.1 Newton is greater than Fmax, applied force is greater than Fmax, therefore the particle will move, the particle will accelerate. So if we simplify this, we can write that if the applied force is lesser than Fmax, that is the comparison that needs to be taken, the particle will not move. If the applied force is equal to Fmax, it is at the verge of moving. This is known as limiting equilibrium. Still, the particle won't move because this is still equilibrium. Equilibrium with friction in it at the verge of moving is known as limiting equilibrium. But if the applied force is greater than Fmax, the particle moves, the particle accelerates, and then we can apply the equation. Resultant force is mass into acceleration. So if I join these two conditions, I can write that if the applied force is lesser than or equal to Fmax, particle won't move. If the applied force is equal to Fmax, that is known as limiting equilibrium, and the particle will only move, will only accelerate if the applied force is greater than Fmax. So what have we learned in this particular video? We have learned that friction is a special kind of force which opposes motion. That is the first and the foremost thing. And the second thing is it always acts parallel to the surface. How can we calculate friction? Fmax, the maximum value, the limiting value of frictional force is given by the formula mu r. What is mu? Mu is known as the coefficient of friction. If the value of mu is 0, that means there is no friction. That's a smooth surface. If the value of mu is 0 upwards, onwards, that means it's a rough surface. And we calculate the value of Fmax. If the applied force is lesser than or equal to Fmax, the particle won't move. The particle will only move if the applied force is greater than Fmax.